Hi everyone. Let's start with something familiar. Kids. If you are a parent or you have been around kids, you know how they come from school like little germ messengers. One child has a sniffle on Monday and by Friday the whole family is down. But what if I told you that behind the scenes, quietly, invisibly, microbes are doing a lot more than spreading colds? They are shaping our gut microbiomes too. And here is the twist. Even when we live closely together, share food, hugs, even bathrooms, we don't share all our microbes. That's what really hooked me. Why are only some gut microbes passed from one person to another? What makes certain bacteria social, able to hop between people, and others more like loners? We often think of microbes as floating freely in the environment, just waiting to colonize. But what we are learning is the microbial sharing is not random. In fact, it seems to follow hidden rules. Let's zoom in. The few microbes that do get shared tend to have special traits. They are anaerobic, meaning they don't like oxygen. They are adapted to live in humans, not out in the world, and they thrive best with repeated close contact. That's why you are more likely to share these sticky microbes with people in your household, those you are around every day, than with someone you just pass by occasionally. And it's not about numbers. Two people might share a home and meals, but still have different microbiomes. Microbial sharing, it turns out, is a very picky process. Even more fascinating, microbial transmission actually maps onto our social lives. In small villages, for example, people who are socially connected, like neighbors or relatives, share more gut strains than those who just live nearby. The microbes don't care about distance, they care about connection. And guess who plays a starring role in this exchange? Kids, especially toddlers in daycare. They are like walking microbial bridges, picking up strains from one family and bringing them into another without even knowing it. No wonder daycare bugs hit hard. Now you might be thinking, okay, neat science, but why should I care? Here is why. Understanding these microbial patterns could help us predict health risks just like we track viruses during flu season. Imagine if we could look at a couple's microbiomes and predict how their gut ecosystems might merge, what beneficial microbes might spread, or what infections might take hold. Or what if we could design smart probiotics tailored not just for your body, but to the microbes you are likely to pick up from the people around you? To me, that's the most exciting part. The microbiome isn't just a medical thing. It's a map of our relationships. It records who we live with, touch, eat beside, and grow up with. It's a biological fingerprint of our social world. So next time your kid brings home a stomach bug or you notice your partner's gut is more sensitive than yours, just remember, not all bacteria spread alike. And figuring out which ones do and why could help us unlock new tools for better health. Okay, thanks for listening.